think I hit start. Okay, boom! I knew it. Okay, we're recording. Whether my 6 hours ready or not. Sorry, 5th hour. I just listened to our recording, and actually the quality was horrible. Hopefully this is working out all right. That my headphones are on. It's actually recording. Shh. Okay. All right. So it's the last, not the last, but last of the one sample hypothesis testing. It's for proportions. You might want to get ready because ready or not, here we go. When I do this is why I wasn't doing this last week. Not that you care, but when I do Camtasia with PowerPoint, it actually mistimes my slides and how I do the animation. So things just randomly just get shoved in there when they shouldn't be. So there's that formula. That was supposed to be coming up later. But as you're writing this down, I can blabber on about stuff just to get your mind comparative to what we've done before. Confidence intervals for proportions were, proportions were when they stated a percentage of the population does this thing. All right, and then we did confidence intervals for that, as opposed to, the mean, the population mean for cars are $30,000 or something like that. That was a different scenario. Proportions are percentage of things do something. So here are conditions that are met so that we can do this hypothesis testing, and it is unique. And I looked this up on another. There we go. That was supposed to come in, but it's already there. This number 2, and I found this in another resource online just to verify what is this. And I guess it's just to ensure that your sample is large enough to be able to do a hypothesis testing that has any significance, has any value to it. So the sample needs to be large enough in order for you to do this. Now, I don't think this is a real big deal. I think we'll be fine on the quiz that these will be right, that we will have values that are greater than 5. Well, let's explain what this means because you probably don't remember proportions. First of all, n is your sample size, the amount of people, let's say, you're testing in this. And P is the proportion or the percentage of people that do a certain thing that you're trying to test. So let's say it was 20%. 20% of the people do this. Well, then what's 1 minus P? If 20% of the people do this, what do 80% of the people have happen? They don't do this, whatever it is. It's the complement. So is the sample size large enough where the proportion of what we're testing times the sample size is greater than 5, and also the complement proportion times the sample size is also greater than 5. If it's not, I guess we could say there's not enough of a sample size to proceed on to get any significant data out of this. Okay, so I don't think we have to worry about this too much. We're going to make sure that this happens. Otherwise, you would not proceed. Formula you will need looks familiar in schematics, but it's in terms of proportions. What is this P hat thing? Just a fancy P? P that's ready to go out on the town? All right, so to speak? Or what does P hat actually represent compared to P? It's a sample proportion. Okay, so P hat is the proportion of some sample compared to the proportion of the population. This is a statistic. This is a parameter. Those common terms that we've been talking about for almost 4 weeks now since we started confidence intervals. All right. All right, so basically you write this percentage down and then you proceed. Oh, by the way, remember back in the day, confidence intervals, when we did proportion confidence intervals, it was always a z-test. So you used your z-chart to find pertinent values. So what you're going to find out is there's just one extra step, and it's this. Do you have enough of a sample size to even proceed? Then the next 5 steps are exactly the same as what we did on that Wednesday last week for a z-test, except we have a different formula and different values, different things that we need to note. All right? Now, on the next page, I think this gets all thrown out at you out of order. That formula will come up again if you're slow with your notes. Oh, there it goes. Look at that. That was when it was supposed to fly in. Anyway, oh, there we go. 2 is thrown in there, and then this is here arbitrarily. That's because of the incompatibility of these two programs. Frustrates me. All right. So steps for hypothesis testing. Number 1, can you do it? Do you have a large enough sample size to make these correlations? So that's the NP greater than 5, or N times 1 minus P also greater than 5. Is it large enough to be able to do this hypothesis testing? Step 2 is exactly the same as step 1 of all the others. State the null, alternative, which one's the claim, and the type of test. And just to reiterate all of these, because at this point it's got to be, you got to get it at this point, otherwise there's something going on. It's based off of, H sub A, determining what type of test it is, right? So that's how those are tied together from day 1 of doing this particular situation. And then number 3, nope, well, sorry, that's when it was supposed to fly in. Now, what do we identify or calculate? The pertinent values for, well, our formula, but also just understanding what is this scenario. Okay, we already know what P is from step 2. That's what our hypotheses are. So what's P hat? So now 2 things will happen. Either they will just give you that probability, or they will say, we have a sample of 400 people. 200 of these people do this, whatever it is that we're testing. What's the proportion then? What's 200 divided by 400? 0.5. So your p hat would be 0.5. You'd actually have to find it by dividing, looking at that sample. And I do have an example of that. So anyway, moving on. Calculate the z-score, round to the 100th. That's our formula. Could have put the formula on this page as well. Put their formula. Then step 5, find the corresponding area. Now it really depends what kind of test that is, how you do that, right? And calculate the p-value. So the probability value from that z-score, looking up your z-chart values. And then number 6 is the same as what we did last Wednesday. It's back to doing this. Make a decision. This is easy for me to say. Make a decision and write a conclusion. Now our decision is back to what we did last Wednesday, comparing P and alpha. If P is less than alpha, we reject the null hypothesis. Now do remember this. When we reject the null hypothesis, what's the claim though? It could be the alternative hypothesis. So when we write our conclusion, it's writing it in terms of what is the claim. I think that's the best way to do this. So let's put it in this way as you're writing this down, and anyone that's listening, you'll get a better feel for this. Say this happens and we reject the null hypothesis, and the claim is the alternative hypothesis. Well, then we say there's support for the alternative hypothesis because this is rejected. So that's how we'd write it. Well, therefore, there's support for whatever this says. Let's say that this happens, and this is the claim. Well, then we would say there is not sufficient evidence to support this claim because this is the claim. I think we're overdoing it otherwise. I don't know what else to tell you on that. Uh-oh, we got a hand up. I got to pause, and then I always get nervous with these two programs. Forget the chart. Okay, all right, here it goes. 2 and 4 should not have come in. It makes me angry. Of course, when I hit it, they'll dance in again. But anyway, you could go ahead and look at this, write it down, and then I'll pause in class. Okay, letting class write down the word problem, blah, 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 blah. Okay, all right, let's think about it. Do we really have to write down the work for checking is this allowed to proceed? The sample is 100 students, and we're trying to claim 20%. What's 20% of 100? 20? I mean, I don't think we have to write this down. These are both greater than 5, and I think in a lot of questions you could surmise that, if that's a word I could use, that has occurred. It feels like something extra to memorize, right? And again, I can only find one resource that backed this up, so it comes from somewhere. I couldn't find it in the little time that I looked. So, all right, let's watch this dance in, even though it's already there. Yay! So step 2 is to state the hypotheses and then identify which one's the claim. Well, medical researcher claims that less than 20% of adults. So that is the alternative hypothesis, no equal sign. And that's the claim. So the null hypothesis is the complement of that, I guess, greater than or equal to 0.2. So with a less than, that means it's left-tailed, which means when we look up z, that is what we're looking up. You know, and then that is the value that I'm going to get for the probability, which is nice. This should not be here at this point. All right. Next thing is identify or calculate. You might have to calculate it, but no, they said in a random sample of 100 adults, 15% say. So they gave us p hat. And at a confidence level of 0.01 when there was 100 people. So now I guess I can dance in the formula. Here it comes. Watch this. Whee! Which was already there. Now, having some problems with getting this typed on the calculator. And still after I go over this, you know, students are still struggling on getting the numbers. Okay, and then still struggling on how to write a conclusion after all this, but finding z values hopefully okay. On an old school calculator, you open up a parenthesis. You close the parenthesis. That's the numerator. Now this is nice. Divided by. Now I know on a like an 84 that's not upgraded, if you just hit the square root button, that in itself is like a grouping symbol saying I'm dividing by anything that's inside the square root, which is perfect. So I don't really need a parenthesis for the denominator. This is the grouping symbol. So again, I'm teaching you how to type this on any calculator because this is actually a little faster than finding that fraction button. 0.2 times 0.8 divided by 100 seems a little bad because, wait a minute, I didn't put a numerator around this numerator, and then a parenthesis, sorry, struggling, I love when I do this, parenthesis around this numerator when there's more things in it. But it's a multiply, so order of operations actually are okay. We actually are all right by just typing this like this. Me going through all of this, you should be testing your ability to write this on your calculator, press enter, and get this number. Okay? And that's what's supposed to be happening. All right? But if you've already gone through that, if you're having success up to this point, then you're fine. Anywho, knowing that this is a left-tailed test, sorry, I got rid of my pen. And again, this is getting a lot of people back to where we're at here. A left-tailed test means whatever I get for this, I am going to look left of that, and that's what I want. And when I look this value, that's how our sheet works. So P is P. I have nothing to do extra. So when I calculate the p-value, when you look up negative 1.25, you should get 0.1056 for an area, which is the probability. Now when you make a comparison, P is what compared to alpha? Well, P is greater than alpha. So we do fail to reject H sub 0. Listen! Because this is it. I'm done. You got to figure this out. And I'm going to get a pen again and compare what your job is after this. Since P is greater than alpha, we fail to reject H sub 0. So that means we could say this is a rejection of the claim, or there is not enough evidence to support the claim. So that is why we say at the end there is not enough evidence or not sufficient evidence to indicate this claim up here, which is what we're trying to make a decision on, let's say. So I'll say it one more time. We fail to reject this. That means we reject this in a way, but I don't want to say it that way. What we want to say then is, okay, since it's a fail to reject, it's a rejection of this. More importantly, it just says there's not enough evidence to support it, because that's what a rejection means. All right, and it's in terms of what the claim was to begin with. I don't know how else I could do this for you. Forget about the chart. The chart stinks. Gross. It's gross in the school. Let's move on. Okay, so it's just humid. I feel like I'm going to get electrocuted by my laptop. Just touching it. Oh, I should have, during all that rigmarole, let you write this down. So, rigmarole. Everybody, number one, can we proceed? Is there enough of a sample size? Do you think there's enough of a sample size? Yes or no? Oh my gosh. Yeah. You sample 425, 55% is P, 45 is not P, right? Come on, 55% of 425 is a big number, greater than 5. I don't think you really need to write this. Hey, look at it's compatible. Now they're flying in order. Okay, next. Which one's the claim? All right, I should have done this more so, you know, I'll say this. Okay, so the claim is more than 55%. What does that mean? Is that H sub 0 or H sub A? That's H sub A, and if you still don't know that, you're behind because that's how all the other ones worked. All right, and then because that's the claim, that's a right-tailed. That you're behind if you don't. Okay, all right, and I forgot what else I was going to say during that. Being all negative. And you said, yeah, I'm done. Okay, oh no, we actually have to do math. From a sample of 425, 255 respond yes. What's p hat? How do I find p hat? 255 divided by 425. Come on. I forgot. I was going to say something. I forgot what it was. I guess it doesn't matter. I'm just going to continue. I think I said something in 5th hour's video about this being 0.6 when this is what your claim is. What is this already, by the way? What's 0.6 compared to 0.55? What's 0.6 compared to 0.55? Greater. Isn't that what the claim is? Isn't this a big, okay, fine, I'm going to say it. Isn't this a big sample? And from this big sample, we have a percentage that's already greater than. So what do you think is going to happen? Are we going to have support for this claim or not support? For the claim. Support. So what's going to happen? There's going to be a rejection of H sub 0, I bet, which means there's support for H sub A. So really, we're overdoing it on that chart, and you know, blah blah blah. That's what I was just kind of. I did say that 5th hour, and I felt like I should say it again here. But anyway, p hat minus p. Sorry, it's small here, but I wanted it to fit, so all this goes on one page. And then the ability to get this on the calculator. Now, do remember this, just for right-tailed tests. This is the schematic of how it works. I don't know if this is going to be in the way. But here's 2.07. I might have to erase this. And if I look 2.07 on the chart, it gives me the area to the left of this, when I really want the area to the right of this. So that is why what you'll see next is how you get that area. Okay? Oh, sorry. I didn't get the area yet. So what is that area to the left? 0.9808. So what's the area to the right of that? 1 minus that. Okay, so that's what I was getting ahead of myself with. Not ahead, I was right where I wanted to be. So we had to look this up on our chart, and we get this. That's the arrow area. I want this area, which is 1 minus that. That's why some people are like robots, and they try to formulaize this. Oh, when I do this, I have to do this. Well, that's not how you really should think, because you're never going to remember then. Too many things to memorize. Okay, you got to actually get into the question a little bit more and figure that out. Okay, so what is 0.0192 compared to 0.05? Less than. When you get a less than, okay, and I did this the other hour, and there were still a lot of not, you know, we still weren't there. So we reject, that is the rejection of this. So since we reject this, we fail maybe to reject. Maybe we could just think of it this way. And a fail to reject means there's support for it. And that's what the claim is. So that's why you see this sentence then, there is sufficient evidence to support the claim. I didn't write it that way though. I wrote what the claim is. There is sufficient evidence to indicate that more than 55% of the whatever watch news broadcast. That's how you do it. Blah! Okay? All right, that's all I got to say about that. Maybe. Got to get this finished.